Hi there, it's Frank. Today we're diving into a cool command called shred in Linux. So stick around and learn how to securely delete files and keep your data safe. So imagine you want to delete a file, but you want to make sure there's no way to recover it, not using any data recovery tool. That's where shred comes in. It's like shredding a piece of paper, but for digital files. So let's open the File Explorer. And you'll see I have some files that I can delete, secret PDF and secret TXT. So I open a terminal window. That's how we're going to use shred. It's a command line program. So first we go to the directory of where the files are stored. We can list the files in that directory and you'll see files there. So with shred, we can delete that file. So we type shred -u. So the -u flag removes the file after shredding. Then -z, that overrides the data with zeros, so it's not readable anymore. And then the number of shredding you want to do. For example, we can set it to 5, meaning the file content will be overwritten 5 times, making it more challenging for anyone to recover the data. And finally, we need to specify the file name, for example, secret.pdf. And you'll see it's now gone. It has been overwritten 5 times. And finally, another override that wrote zeros in its place. So it will be basically impossible to retrieve that file now. Now, you can do this command for any file, for example, secret.txt, and you see the file is deleted. And the difference, so that's what you can use to delete files. So it overwrites the content 5 times and it does a final override where it writes zeros. So why would you use this instead of rm-rf and then some file name? I mean, that would work too, right? Yes. However, even though you might be thinking that, there's a big difference. So rm-rf deletes a file, but only the connection, so it leaves the data behind. So many data recovery tools can still access the data. If you try to one of those tools to recover it, it might still be able to get the original data back. But with the shred command, it's really shredded, like shred a piece of paper. It's no way to recover the original data. So it's a more secure option to delete files using shred, because then it's not recoverable using any data recovery tools. So the key difference here is shred focuses on secure deletion, overwriting the file contents and preventing easy recovery. And rm-rf or rm, that command removes the files and directories, but it doesn't necessarily securely delete the data. So it might be recoverable using data recovery tools. And what it does, it simply marks the data or the space on the disk available for reuse, but the data might still be there if you use the rm-rf command. So if you use this command, let's say secret.txt. So for this command, the data still exists on the disk, or it might still exist on the disk, deleting, because it deletes the mark that is deleted, but the data is still there. And with the shred command, it really gets removed from the disk, overwritten 5 times and then overwritten by zeros. So it's not there anymore. So in a nutshell, shred is your go-to command for saying goodbye to files, making sure they're gone for good. So stay tuned. We're going to cover much more cool stuff. Hi awesome people, welcome back. It's Frank. We're going to talk about something super cool. So have you ever wondered, you have a lot of files on your computer, did someone mess with your files, maybe a hacker or someone else? How can you know if someone has messed with your files? So one way is using file integrity checking. So it might sound complicated, but stay with me, I'll explain it in easy steps. So first, of course, we need to have some files. It might be text files, PDF files, images, anything, any type of file. You can figure out if someone messed with them using a unique fingerprint. So how do you get such a fingerprint? You can do that with a terminal. So either we can right click here and open terminal wherever your files are stored, or you can simply navigate to the directory using the terminal. So let's say we are in the documents directory here. You can copy it, cd the directory, and we are there. You can list the files, and you'll see we have the same files. Now, of course, this is the slow way. The fast way is right click, open terminal here, and we're in the same directory without having to type the cd command. Okay, so let's get back on the topic. How do you know if someone messes with your files? Well, you can use the unique fingerprints. How do you get a fingerprint of a file? You can use the command ssh256sum. That will give you a unique fingerprint of the file. For example, we are getting the fingerprint here of the file secret.txt. You'll see there's a file. Let's change the content a bit. So it has the word secret in it. We can get a unique fingerprint using this command. So ssh256sum with the file name. And you'll see that gets the unique fingerprint of that file. Every file has a unique fingerprint. So if we would check the other file, you'll see there's another fingerprint. Now this fingerprint is quite long, and that's because we use ssh256sum to get the fingerprint. There are other programs that allow you to calculate the fingerprint that are slightly shorter. For example, there's md5sum, which you can use to create a unique fingerprint. However, md5sum is not the most secure, but it does generate shorter codes, which might be easier to keep track on, depending on your preference. Anyway, so ssh256sum is a lot used these days, and you can get unique fingerprints. For example, we can get a fingerprint of example.txt. And now let's say we change the contents of this file completely. We save the file. And now let's check the file again, the fingerprint, and you'll see it also completely changed the fingerprint. So you can keep track of files and their fingerprints. For example, you can print them or store them somewhere else, and then you can check over time if those fingerprints have changed, then you know someone has been messing with your files. So you can do that for any file, and even small changes, they will give a completely new fingerprint. So for example, if I open this file and I make a tiny change, so one character change, one character has been changed. And let's say we run the command again, and you'll see it generates a completely new fingerprint. And it doesn't really matter whether you use ssh256sum for that or any other online fingerprint tool. It has the same idea. For example, if I use md5sum with the file name, you'll see we get a fingerprint. Let's change the file. So we change the file completely. You'll see it generates a completely new fingerprint. Let's do it again, but now change one character. And you'll see the fingerprint has again changed completely. So with this tool, ssh256sum or with md5sum, you can quickly create a fingerprint of a file. In that way, if you keep track of the fingerprints of files, you can know if someone has messed with your files. And even like tiny changes, they make completely fingerprints. So it doesn't really tell you if someone looked at the file, but it does tell you if someone changed the file. So if anyone tries to change sneakily your files, it can be text files, but also images, zip files, or anything else, you know that someone has been modifying one or more of your files. So with these commands, you can know if someone has been messing with your files. So it's your security guard to ensure your files are untouched and safe. Having a superhero for your data, where you use md5sum or the more newer ssh256sum. Generate different fingerprints, however, both the same idea. So unique code for your files. If someone messed with your file, the code will change. Now, of course, if you want to keep track of specific files, you would have to keep track of those fingerprints as well, because let's say you never keep track of them and someone changes your file. And you might think that this is the original code. So you'll want to keep track of the original fingerprints, and then you know if the file has been modified. So really cool. You can do this for any files, so text files, image files, anything else. Hey there, awesome people. You might be in a situation where you want to transfer files from one computer to the other computer. One way to do that securely is using OpenSSH. So in this video, first I'll show you how you can set up an OpenSSH server, how you can make your setup ready for that, and then I'll show you in the next video how you can transfer securely files from one computer to the other computer. Okay, so first we're going to set up the OpenSSH server. We open a terminal, a small terminal here, and first we'll update the package list. This is for Ubuntu Linux, so if you use another Linux system, use your package manager for that. So we simply run the update command. For Debian and Ubuntu system, it will be this command. Use Fedora, you will need sudo dnf update, and it really depends on which Linux system you're using. But it's just a general command for updating the package list, so it will be different on every Linux system. Next, we'll install a package called OpenSSH server. So with this command, we will install the program that we'll need to securely transfer files on the network or over the internet. So this is the name of the package that we're going to install. Press yes, and you'll see that installs that software. Now, it might take a moment, but it automatically sets up everything. So there's really not much to do, except that you might want to set a secure password for your user. So either do that using the settings screen. So if you're new to Linux, you might want to go to the settings screen, going to users and then setting the password there, using the command sudo passwd for changing the password with the username. So this command will change the password. And we type sudo in front because it's an administrator command. And this is simply the username of your account. So if you didn't set any password yet, do it now. And set some secure password. So don't pick any password that is really easy to guess, otherwise you might get some warning or it will refuse to set the password. So next, the password has been set. You'll need to know the address of your computer. That is the network address, the unique identifier of your computer. So just like cars have license plates, computers, they have unique network addresses. And to find the network address, you can either find it using the graphical interface or using the command IPAS. So if we type IPAS on Linux, we will see a bunch of data, but the one we are interested in is called INET, so internet, and that will tell you your internet address. So that's the address, digit number. This slash is not included in the address. So this is the internet address. Another way that you can quickly find your internet address is going to activities, settings. This is for Ubuntu systems only, but other Linux systems also often have graphical interfaces to quickly find the unique address of the computer, settings, and you'll find the network address of the computer. So that's the same address that we were looking for. Site network and then clicking on the little wheels there. Okay, so in most users probably use the APAS command and then getting the enet. So if you want to filter all this data, because it's quite a lot, you can type grep enet. Then you'll see a bunch of addresses, and the one you will need is the address starting with 4 digits. So the other ones are not your address. Sorry. So this one and this one you can ignore. This is the local address. So it will be the one left, which usually start with 192. That is your network address. And you'll need that later on to connect to transfer files to this computer. Now, if you want to verify that the SSH server is running, we can type the command sudo service SSH status, and it should tell you OpenBSD secure shell server. So it's a software created by the people at OpenBSD, which programmers that are really focused on security. And the program is secure server, so it should be active. If it's not active, it means it's not correctly installed. And to install it again or find out what's the problem. See this, it means that it's running, and you can then connect to it using another computer. To get out of this screen, simply press the Q key, so the Q of quit, and you'll see we are back in the terminal. Welcome back, Linux users. So Frank here, and we're going to step into the world of secure file transfers. In the last videos, you set up the SSH server on one of your computers. Check if it's running, sudo service SSH status. and it should tell you that the service is running, just to verify. So if it's running, then let's get ready to transfer some files. Of course, we should have some files to transfer, so let's see if we have some. Use the documents directory before, and you'll see we have some files there. I'm going to open the terminal in that directory. It can be any directory where you have files that you want to transfer. So first, why do you even care about secret or secure file transfers? Because someone else might be listening on your connection and then making copies of all your files. That means that the data is not just your data, but someone else is on the line getting all of that data, which is happening quite often in the real world. So to prevent that situation, what you can do is use secure transfer. That means that everything on the line is encoded, encrypted, and means that its unreadable text is only sent over the wire and not readable text. So anybody else on the line cannot read the data. So that's the idea of secure transfer. So there are two tools you can use for that, SFTP or SCP. SCP stands for secure copy. So it works similar to the regular copy command, but slightly different. Let me show you how it works. You type SCP, then the file name. Now, of course, we need to know which files are in this directory. So we have two files. Say we want to copy secret.txt. So we type SCP secret.txt. And then we want to connect to the other computer. So we need the username. You'll see the username is Ubuntu of the other computer. In case you don't know, you can always type who am I. And then @ so just like email, you'd use the @ symbol. And then the network address of this computer. Now remember, we can type the command IPAS. And then you can find the network address of the computer. Or alternatively, you can use the settings screen to find it. You could go to network, then click on the little wheel there, and it will show you your network address. So that's the one you type. Whichever way you get the network address is fine, whatever you prefer. There's no best way in that sense. Then it knows that we want to copy this file to this computer, but it doesn't know where it wants to copy that file to, right? We didn't specify any directory. So let's say we just want to store it in /home/Ubuntu. So if we check pwd, the current directory, that's the directory we're in. So that's where we could store it. And then we press enter. Type yes if you see this message. It will ask you the password. And you'll see the file has been transferred, secret.txt 100%. So if we take a look in the files, you'll see we now have secret.txt on this computer. It has been securely transferred. So SCP is one of the files you can use. Now it might look a bit cryptic, but basically it's the same as copy. So with the copy command, you have copy source destination. And basically it's the same thing. So you have secure copy, the source, which is the file. And the destination is whatever user at the computer. And of course you need to specify some path, so maybe home, Ubuntu, downloads, or wherever you want to store the file. So that's the SCP command. That's one way you can transfer a file. There's another tool next, which is Secure File Transfer Protocol, or SFTP. Now this works slightly different, so you're not copying a single file, but it's more like a command line interface. So we can type SFTP, then the username, at the computer's unique address, press enter, type the password, and now we can use browse around. So for example, we can list the files in this computer. You see, we can now access all of the files in that computer. We can upload files. For example, we can say put example.txt. It then uploads that file. So if we take a look here, example.txt is now uploaded. Also download files from this computer. So let's say we go into the downloads directory. You'll see there's a downloads directory here. List the files, and you'll see there is a get JPEG file on this computer. So to download it, we can type the get command, get JPEG, and you'll see that's downloaded the file. So with this tool, you can upload files and download files. So to upload, you use the put command, and to download, you use the get command. You can use most of the traditional Linux commands to navigate the file system. So both TCP and SFTP encrypt all your data during the transfer. So that keeps eavesdroppers away, so anybody listening on the connection won't be able to figure out what is being sent over. All of the data is encrypted. So basically they just see noise if they were to eavesdrop on the line. You have it, SFTP and SCP, trusty companions for secure file transfers. It's important here that in order for this to work, you need to have an OpenSSH server running. So this program needs to be running. So if you have this command, it should show active, otherwise the whole thing doesn't work. You can have an SSH server on any Linux computer, but it also works on computers and Windows computers. Now, on Windows computers, you might have to custom install that. You can activate it, but for any computer supports SSH. So an SSH service needs to be running on the file you want to download and upload files through. But it's a secure way to transfer files on the network and also on the internet. Thanks for tuning in. I hope you found this useful. Until next time, and happy secure file transferring. Hi everyone, welcome back. So let's talk about the main concept here, which is a zip file. So a zip file, you can see it as a digital backpack. It's a single file that can have many more files inside them. So easy to send over the internet or carry around. It's one of the more famous archiving methods. That's why we're starting with zip files. Not necessarily because it's the most secure, but because it's the most familiar with everyone. So let's say we have a folder. We have a folder with multiple photos inside. And what we can do is create a zip file from that. So on any Linux system, we can right-click, click compress, and save it as photos.zip. If we then take a look at that file by double-clicking on it, we can see the photos are inside. And a single file contains all of those pictures or the entire contents of photos. So if we were to delete this folder, we can then right-click extract, and we get the same photos again, the same files. So all of them are stored inside this zip file. Now you can do the same thing from the command line. So if we delete it, we can open a new terminal, and from here we can create a zip file. Typing zip -r, the name of your zip file, and then the name of your directory. So in this case the directory is photos. You'll see that creates a zip file with those with all of the files inside. Now this doesn't have any security whatsoever right now. So what you can do to secure a zip file is to add password protection. Now how do you do that? So we delete this. Then we need to add another parameter to this command, --encrypt. So that will add a password to the zip file. So just adding that little flag, --encrypt, and the zip file will then be password protected. It will ask the password right away. And you'll see we have a zip file. Now if we were to delete the photos and try to extract it, you'll see it asks for a password, and if we have the wrong password, it doesn't extract anything. So you'll need to have the right password in order to use the files. However, this is not flawless, it's not the most secure way. If we double click on it, you'll see that while it's password protected, we can still see the directory name, and we can still see all the names of the files. You'll see in order to look at the files, they are password protected, but not the structure of the zip itself. So we can still see all the directories that are part of the zip, and also all the file names, general information. And so it's possible to add a password to a zip, but it might not be the most secure way to store your files. Now, if you want, you can of course extract a zip file using the command line, and you'll see it also asks for the password. So it does create a directory, but without the password we can't access them. Of course we know the passwords, so we can extract them, and we are now able to access all the files again. Zip files are a way to easily add some file protection using zip. Again, easily add a bunch of files together and add password protection, but it's not completely secure in that someone has a zip file and doesn't have the password. They still has the folder names and they also have the names of the files. So there are better alternatives to store your data more securely, in that the file names will not be known either. But zip files are one of the most famous archiving methods. That's why I covered it first. And just to understand the general concept of archives, which basically is a collection of files. So one or more files can be put into a single file. Zip is one of the options. On Linux, you can quickly see a graphical of all different archiving options. So if I do right click, compress, you'll see by default zip is selected, but there are other options to secure your file. For example, 7-zip is one option for securing your files. For archiving your files, but there are other like tarxit. Depending on which system you use, some might be more familiar than others. It's quite commonly used on the internet. It's more famous than, for example, tarxit or 7. In the last video, we made a zip file using this command. So a password protected zip file. Now with a zip file, there's a problem. Double click on it, we can still see all the names. So anyone who has access to the zip file can see all the file names and all the directory names. Those are not password protected, just the files themselves. So let's add another layer of security to this. We're going to use to protect our files using a tool called GPG. First, we create a password protected zip file using this command. And then we're going to encrypt it using GPG. So we're going to type a command in the command line. So this command, highlighted here, this command will prompt you to set a GPG passphrase, so another password, and that is an additional layer of security. So you will need 2 passwords to gain access to that zip file. And if someone then accesses your zip file, they cannot see the file names, the folder names, and they cannot see the contents. So they will need 2 passwords to get access to your file. So let's press enter. And you'll see we have to be very specific about the file names. You'll see here capital photos, so capital P, and here we have lowercase. So make sure that the file name is exactly the same. You press enter with the command. You'll see it asks for a password, so pick a good password. For demo purposes, I just pick a very simple one. And you'll see that created a new file, photos.zip.gpg. You'll see an icon here with a little lock, meaning that the archive is encrypted on top. So now if I double click it, see the archive tool doesn't open. And if we try to open it with an archive manager, so if I right click, open with application, archive manager, you'll see that it just says could not open. It's not a zip file. So that's because we have scrambled the whole file. So now it's no longer visible file names and the folder names. We still have the original file, so we can delete that because all the files are in this file. There's 2 passwords now. So it is password protected zip file, and on top there's the GPG layer of security, which means it's been scrambled as well. In order to access the files again, if you have such a file, you would have to extract it twice. So first you can do that with GPG. Now GPG on a computer has the tendency to remember passwords you typed before. So let's see if we will need to type the password on this computer. It might be that the computer still remembers. You'll see it's been extracted it with the password it still has in the computer's memory. Normally, if you send this file to someone else, they would have to specify the password. And you'll see then we have the zip file, which then the file names and the folder names are visible. You still need the password to extract it, so you will do unzip photos.zip and then the passwords to extract them. So that would extract of them. So you can use GPG to add another layer of security. You would need 2 passwords, send this zip file by email to someone or to yourself on your computer, you would have to type 2 passwords to extract it. So you type GPG to extract it with the file name, and then you would have to unzip it passwords. So 2 passwords will be necessary to access the file. So just to recap, a quick recap, this is how you would add add the zip file, add another layer of security. Of course, you can do that multiple times even. However, then you have to remember multiple passwords. So a single time should be enough. And to extract it, it is without the flag, so without the -c parameter. So this is extraction, and this is adding the layer of security. So you can do that also with other types of files, but for example, we're using password protecting a zip file. So we added a password for basic protection with the zip command. So with this command, we added basic protection, and then with GPG, we added layer. So this adds a basic layer. See, that creates photos.zip, and then with GPG -c, we add another layer of security. And you'll see we now have that password protected file that is even unreadable with any archiver. So we know it's a zip file because it's in the file name, but we can't see the folders, we can't see the original file names, and we can't see the data without knowing the both passwords. So that's it for password protected zip files. I'll see you in the next videos. Hey, and welcome back. As you may or may not know, disks and data storage can often fail. Now, depending on the quality of the device, of the hardware, it may fail sooner or later. For example, old floppy disks, they might not last more than 2 years. And you see that the newer technology can last longer time, but that's a little bit in the best case. In a lot of cases, those disks break much sooner. They say here 50 years, well, most likely the disk breaks somewhere after 5 years or 10 years regular use rather than 50. So they are a bit optimistic in this estimate. But one thing to keep in mind is that or data storage breaks, and it won't last for a long time, certainly not more than 100 years. So it's a good idea to make backups. You never know what happens. The disks may fail, the electronics may fail. So it's a good idea to make copies of your data, of your important files. One way could be using those archives that you learned about in the previous videos. But an alternative could be with a different strategy. So not just having a single file backup, but having multiple backups. And this is known as the 3-to-1 strategy, where you have 3 backups on 2 different locations. Now, why 3 backups and on 2 different methods? It's like, let's say you have a backup on the flash drive and maybe on solid state, and let's say then the solid state fails, backup, but it fails, then you still have a backup on your flash drive. So if you have 3 different backups on 2 different, or at least 2 different media and 2 different locations, it's less likely that your backup strategy will fail. Things always fail in the wrong moments, when you're busy with work or not in the time that you need to access your files. It's good to have multiple backups on different devices so that if something fails, you can always access your files. Now, there are various methods in which you can make backups. The most easy ways could be, of course, to simply create an archive. So let's say we create some archive. And then copying that over to a USB flash drive. So that works if you have a few files that might work for you. You can, of course, copy or backup your entire home directory. So if you go to the home directory, you might simply add your entire home to a zip file. Now, that might or might not work depending on how many files you have in there. So not the best strategy, but it is a possibility. You can use a dedicated backup tool. So on Ubuntu, you have the backups application, you can use that. Let's say you click create first backup, add some directory. For example, let's say we want to backup the photos directory. Click forwards. You can select your storage location, so either Google Drive or one of the other local or network server. Then you can create a backup. So there are different strategies to create backups. So if we do a quick search for backup, you'll see different command line tools pop up, and some are not related to backups. But for example, there's DJTab and Duplicity, different backup tools. You'll find rsync here, which you can use to create a copy. So there are different tools for that. But the important with backups is not so much the tool, but rather that you have backup on different media. Because those electronic devices, they are gonna fail eventually, maybe sometimes sooner than later. So you want to have different media backups and also different locations, because something could happen where, for example, your disk gets stolen. Then you want to have a backup on another location. For example, if there was a robbery or some other situation like that, then it's good to have backups not just on one location, but on multiple locations to prevent that situation. So you want to use the 3-2-1 backup rule. So you want to have at least 3 copies of your data, 3 copies of your file on at least 2 different devices. For example, the flash drive, could be other types. So for example, maybe an internal disk or an external SSD disk. At least 2 devices and 1 offsite copy. So at least one copy that is not in your home. So for example, the cloud is not in your home. It's another geographic location. It could be you store your disk somewhere in a safe. Or it could be you have a disk in your car. And so you want to have at least 1 copy that is not physically in the same location as your home or as your office. So you want to have at least 3 copies. So that way, if one thing goes wrong, if a copy doesn't work, you have at least 2 others. At least 2 devices. Because you don't want to rely too much on the internet. Maybe the internet doesn't work or some other problem. Modem breaks down or some situation like that. So 2 different devices where you have your backup and at least 1 offsite copy. So at least 1 copy that is outside of on a different geographic location. So it could be the cloud, could be somewhere else, or maybe in the car, in another other location. So that's the main strategy to keep in mind. So just making a single backup is not enough, because a single backup is not a backup. Can fail, disks can fail, and there can be other problems. So you want to have at least 3 data copies, 2 devices, and 1 offsite copy.